The beginning part of this next chapter is stuff that you guys are a little bit familiar with already, simply because that's the way we've had to enter information online. And so we're going to talk about rational exponents and nth roots, again, which you guys have done a little bit. If you have the following relationship, okay, so if you know that b to some power is equal to a, then this number b is called an nth root. Of the value a. In other words, what it's saying is b is equal to the nth root of a. So that's all, like, terminology-wise, if you hear me talking about nth root, and that's what I'm talking about. By putting it in this radical form, the only other distinction that you need to make sure that you can make is the fact that I'll usually refer to this number inside the radical as just a base. Right? And then this number, the nth root, is called an index. Okay, so I don't think I've used that term with you guys yet, have I? Okay, so anytime you look at a root of some sort, whatever number that is called your index. So if you had something like this, what is the index? The index is 3, and it represents the cube root of 2. And notice how I wrote this. Okay? Anytime you need to write your answer in radical form, and it's the cube root, you're going to just spell that out. Cube and then RT. Okay? We've already discussed square root. SQRT is how you would enter it online with the parentheses around whatever numbers inside, or whichever numbers represent this base inside. Okay, now, does a square root have an index? Okay, let's think about taking this example that they give us right here and kind of going backwards. If we know that root 2 is equal to b, then 2 is equal to what? B squared. So what is the index? Square, 2, right? So in a square root, the index is an unwritten 2. Okay. All right, if you have something that is the fourth root, okay, the way that you will write that out is you'll spell fourth root 2, and so on. So fifth root, sixth root, whatever. I'm not going to go like overboard on that. But if you see something that is a radical with an index of something other than a square root or cube root, which are a little bit easier, just that have their own special names for them, the powers or the indices. Anything beyond that, just spell that ordinal, the positional number, spell it out, and then add RT, and then put in parentheses whatever's in there. Okay. All right, so you're going to see a couple problems that will show up on the homework that will ask you to find nth roots. Okay, and basically what they're saying is, if I give you n is equal to 2 and a is equal to 25, find the nth roots of that. Okay? And so if you were looking at this, what you'd want to do is you'd want to kind of transform this back into that form that I showed you before. So if you know that b is equal to the nth root of a, so you're going to kind of start with this information. When you plug these values back in, you're basically solving for the b values here. So if you took, or if you had a 25 here, you had your unwritten 2, here's your index and your b value. If you moved backwards, what would you have to do to solve for b here? or I'm sorry, not solve for b, but get rid of your radical here. What would you do to both sides to get rid of your radical? You'd square both sides, right? You undo the operation. So b squared is equal to 25. So what values could b equal if you're going and finding these nth roots? What number can you square to get 25? 5. Is that the only one? And negative 5. Okay. So when you are finding nth roots, you do have to, for even index, any n value that's even, you have to consider both the positive and negative roots. Okay. Now, this is different. This problem right here, finding the nth roots, is different than evaluating the square root of 25. Okay. And this is, I'm spending time on this just because this is really confusing, and I think a lot of times in Algebra 1, when I've taught those classes, this concept is confusing, and then it trickles down year after year. But the square root of 25 is equal to what? Is it 5 or plus or minus 5? How many say plus or minus 5? How many say just positive 5? How many refuse to answer because you don't even want to risk looking like you made a mistake? That is the easy way out. All right, the answer is just 5. And so this is kind of what I'm saying is, because they introduce this finding nth roots as being equal to the positive and negative root, when you evaluate something, like, you have to take this sign into consideration. So when it's listed as root 25, you're simply evaluating the, remember when it's positive, you don't write anything, it's just the positive root 25. Right? If they wanted the negative root 25, they'd have to include that separately. Right? But in these types of problems, if your index is even, what it's asking you to do is to put it back into this form. Now, if I come back down here and I say, compare this versus solve x squared equals 25, then what does x equal in this case? How many think positive and negative 5? How many think only positive 5? And then again, a few of you refuse. All right. In this case, this is the one that is plus and minus 5. Okay, so do you guys see how that can be confusing? I mean, obviously, it's very confusing. Okay, so here's the way that I want to make sure that you kind of have the distinction. Okay, if you are evaluating any radical with an even index, an even number right here, and it's not part of an equation, so it's not saying x squared is equal to some number, okay, where you're not isolating a variable, it's just going to be the positive. So the solution for root 36 is just 6. What about the square root of negative 36? It's non-real, right? You can do it in the i's, the complex numbers. Okay, but you're not going to get a solution in the real number system. Okay, but if I compare that to x squared is equal to 36, now when you solve, like if you square root both sides to solve an equation, so you get x is equal to the square root of 36, you have to take into consideration the positive and negative in this. So now you do get the plus and the minus 6.